everyone. Today we are going to be covering a little lesson on quadratics. Okay, quadratics are a review for you. You saw them in Algebra 1 and Algebra 2. If you have questions, feel free to email me, but most of this stuff, actually all of this stuff is review that you've seen before. But again, you have any questions in addition that I don't answer here, feel free to email me. So make sure you watch this video in full. I haven't been killing you on work. If you did not do the Desmos from the other day, I put it as a little quiz grade because so many of you did not do it. Again, I haven't been kind of killing you with work, so I would suggest doing that if you did not. And if you did not, email me and explain to me that you complete it. Maybe you'll get a little bit of credit. So first off, a quadratic function, a function with the highest power is 2. So a u or an upside down, sometimes a hump, but we've all seen a quadratic. So there are many different things we talk about when it comes to a quadratic. None of these terms are new to you. So we actually looked at domain and range a lot in the beginning of the year. X-intercepts, Y-intercepts, decreasing, increasing. The only ones that might be slightly new to you right now, new as in this year, axis of symmetry, vertex, and end behavior, and we'll talk about all of that today. So what is a vertex? So a vertex is a point where it changes direction. So when it comes to a parabola or a quadratic, it's either going to be the max or the min. So that's where the function is changing direction. So if it's facing upside down, it would end up being a max. Down here, the vertex is the minimum. Axis of symmetry. So whatever the x value of the vertex is, the axis of symmetry goes through that. So it's just a kind of imaginary line that would cut the parabola in half, and you'll see that as we get through there. X-intercepts, we know that that's where we hit the x-axis, whereas a y-intercept is where we hit the y-axis. Okay? Decreasing interval is where our function is going down to the right. Increasing is where it's going up to the right. Think if we were on this one, it's decreasing. If we had a little guy up top, he would slide down the hill. In this case, if we had a little guy at the bottom or on the left, the only thing he could do is go up the hill. So increasing, decreasing. Domain, all of our input values. We know that we typically write our domain in like interval notation. For a quadratic, our domain is always going to be, unless it's a word problem, negative infinity to infinity. The range, in the other hand, can change. Okay, the range can change. We'll talk about that, but that's all of my y values or my outputs. And last but not least, end behavior. So there are a few different end behaviors we'll discuss, but when it comes to a quadratic, we want to say, okay, so how does the end of the graph, so what happens at the end? So typically we write it as x goes to positive infinity or negative infinity in this case. What is my function doing? Where is my function going? So this part doesn't always change, but this part will. And it'll either be in this lesson, it'll either be, okay, it's going up to infinity, or it's going down to negative infinity. And I may skip through these notes and cover some of the stuff when I get back, but just bear with me as I'm going through it. Okay, so this one says, first example, identify the following key features of the graph. Okay, so let's start with the domain. So for any sort of quadratic, anything that's a u or a v, the domain's all real numbers. Don't waste your time. It's all real numbers, negative infinity to infinity. Please write negative infinity to infinity. Range, little bit of review. Range is your lowest y value to your highest. So we always go from bottom to top. So the lowest y value is -3. And then it's going all the way up and up and up and up to infinity. So the range would be -3. We use a bracket because we can equal -3 because we have a solid dot. Sorry about the Smart Notes logo. And it's going all the way up to infinity. The arrows tell us that it's going up forever. Our x-intercept, so where do we cross the x-axis? So in this case, we cross the x-axis at 1 and 3. So our x-intercepts are 1, 0, and 3, 0. Remember, they're points. 1, 0, 3, 0. Our y-intercept is where we cross the y-axis. Okay, in this case, just be very careful because this one kind of looks like it's crossing 8, but it's actually crossing at 0, 9. Again, it's a point. My y value is 9. And axis of symmetry and vertex. So vertex, we said, is where we change direction. So in this case, our vertex is our minimum if the graph is facing upward. It's our lowest point. So that is our vertex in this case. So what is the point for that? 2, -3. So I'm going to do the vertex first. So 2, -3 is the vertex. And the axis of symmetry is an imaginary vertical line that goes through whatever the vertex is. All you do is you take the x-axis of the vertex. So it would just be x equals 2. So x value of vertex. And it's an equation, don't just write 2. So x equals 2. Okay, and feel free to pause as I'm going through this. Email me if you have any questions. I should be back the next class period, so I'll clear up anything that you have, but make sure that you watch the video. Max and min. So in this case, I'm going to circle which one it is. So we said that it only has one and it has a minimum. This one does not have a maximum. That minimum is the vertex. So 2, -3. Easy enough there. And the last two. So this may be the ones where we might have not seen this in a while. So where is the function increasing or decreasing? So increasing, when we do this, I don't know if you remember from the beginning of the year, but we only use x values and they're intervals. So just kind of like domain or range. So we're going to say, okay, where is the function going down to the right? Where is the function going up to the right? So it switches direction at the vertex. So the function is decreasing from, we're using x values, so it's going out and out and up forever. So from -infinity all the way until this x value of the vertex, the x value of the vertex is 2, it's decreasing, and then at 2 it switches directions and it's going to increase. And remember, it's going to keep going out, now, up forever. So from 2 to infinity. When you're doing a parabola or quadratic, they're the same thing, but when you are kind of labeling all this information, the function is always going to kind of change at the vertex, whatever the x value of the vertex is. Last but not least, when it comes to end behavior, you're always going to write it like this when it comes to a quadratic, and we'll handle the other cases when I get back. As x goes to plus or minus infinity, f of x goes to, this is always the same for now. You'll always write that. What changes is the part I'm going to fill in next. So you always start your end behavior this. So this is saying as x goes to the left, what is my function doing? Well, my graph is going up and up and up and up towards infinity. And as x goes to positive infinity out to the right, what is my function doing? It's going up and up and up and up. So on both sides, it's going up and up and up and up and up forever. So that means it's going towards infinity. If the graph were upside down, everything in purple would be the same. And instead, so say it was like this instead, the final thing would be -infinity instead because it would be going down, but everything else would stay the same. That's the only thing that would change, the final. That would be -infinity instead. Okay? Again, you have any questions, you can pause this, feel free to ask them. Let's keep going. Different forms identify different key features. So when we are in standard form, there's a few things that we point out. Standard form tells us the y-intercept. So the y-intercept is going to be c. From the standard form, we can also find the vertex, which we'll talk about in a little bit, but that's -b over 2a, and then we plug in to find the y value. And this will also tell you the end behavior. So if this number in front is positive, the function is going to go up towards infinity. If that number in front is negative, then the function is going to go down towards -infinity. Okay, so that kind of tells us the end behavior. What is it doing? Is it going up towards infinity or down to -infinity? Which way is it facing? So if we look down here, we can quickly find just a few things. The y-intercept will be the last number here if it's in standard form. So the y-intercept will be 0, -3. But it will also tell us the end behavior. Not only does that, but the graph also tells us the end behavior. So since the number in front of the x squared is positive, we call that a, it's greater than 0. Then the end behavior would be as x goes to positive -infinity, f of x goes to, remember this is always the same, but since it's going up like before, it would be going up to positive infinity. Okay, so it's just a few things, and again, we'll talk about vertex in a little bit, how we find that. Factored form, or intercept form. So it can be known sometimes as the factored form or intercept form. this can tell you what the x-intercepts are. So for example, you see them here. So what are the x-intercepts? Well, it's like if you were to set this equal to 0, they'd be x equals 1, x equals -3, 1, -3, right? AKA intercept form. And then vertex form tells you the vertex. So in this case, HK is the vertex. So make sure you pay attention to the negative here. So in this case, we switch the sign for the x. Remember, x's are always opposite. So my vertex would be -1. We keep the y value the same, -4. And if you look on the graph, my vertex is indeed -1, -4. Okay? But keep in mind, all of these, if you look at it, represent the exact same function. They're just different ways to write it. So different ways to write it show different things, but it's all the same function, and we can use different ways to also graph it. So we might put it into a different form to graph it or analyze certain key features. Okay. So for example, for A, this is in vertex form. So I'm going to analyze the vertex. So the vertex in this case, switch the sign for x. X's are always opposite. So the vertex would be 5, 7. And then we'll learn how to graph it from there. This one, we look, the value in front. This is in standard form. I'm just going to abbreviate standard. The value in front is negative. So this function, the end behavior, as x goes to positive, negative infinity, this function is going to go, the value in front is less than 0, down. So go down to negative infinity. So this function would basically look like that quadratic. We can also see from this the y-intercept is -6. So 0, -6. And we can find the vertex, which we'll talk about in a little bit. And then from the last one, this gives me my x-intercepts. This is intercept form. And my intercepts are, solve it. So set them both equal to 0. So my intercepts would be x equals 4 and x equals 8. So I get different pieces of information from each form that I can write. Okay, so before we get quickly into graphing, because I want to keep this video short as possible, you want to write the equation of the quadratic based on the graph. So looking at this, we have a few different options on how we can write the equations. I'm going to pick kind of the simplest form I can in this case, which is, let's look at the vertex, right? So we have the intercepts, we have the vertex. So I'm going to, looking at it, so f of x equals, actually, we can do these when I get back. So skip these examples for now. We'll do them when we get back because they're easy to handle before we get into word problems. So go down to where it says graph a quadratic, intercept form. So when we're in intercept form, okay, so we're going to find and graph the vertex, and we can also graph the intercepts, and we can connect our points. So when we are in intercept form in this case, and we are graphing our quadratic, the easiest thing to do is first, we can plot the intercepts. So the intercepts would be x equals 3 and x equals -1. Okay. And if we want to find the vertex, what's the easiest way to go about it? Well, I gave you an equation up here. If we are in intercept form, the easiest way to find the vertex, so these are my x-intercepts, is to say, so we want to add those two and divide by 2. We want to find the middle because the vertex is going to be in the middle of these. If you can do that without doing it, you're going to get 1, that's fine. So add the 2, so -3 plus 1 is going to give me -2. Divided by 2 is -1, just plugging in using this formula. Remember, your factors are the p and q. Oh wait, I forgot to switch them. That's my fault. So usually a +1 here. My apologies. So we take 3 minus 1 divided by 2. And again, it should be directly in between -1 and 3. So it's just going to be 1. And then you just plug that back in to the original to get the y value. So 1 minus 3 is negative 2. So we're going to get 2 times negative 2 times 2, which just gives me that my vertex is 1, negative 8. So 1, negative 1, 2, 3, 4, 5, 6, 7, 8. There's my vertex, and that's all I need. If I can find those, I can plot the rest of my function, and that's all I need to graph my parabola. And of course, you can graph it a little bit nicer than mine looks. There we go. Okay, I can also find other key features from here. So again, looking at this, finding the y-intercept. So a good way to find a y-intercept if you don't do it from the graph is to plug in 0, because when we're finding a y-intercept, our x value is 0. So 0, so we get 2 times negative 3 times 1, which is just 0, negative 6. So that's my y-intercept way down here, which I passed. So I have my x-intercepts, my vertex, my axis of symmetry would just be x equals 1. It's the x value of my vertex. My vertex is also my minimum. It's my lowest point in this case, so I don't have a maximum, but my vertex is also my minimum. So I handled that, my intercepts. And then we can leave increasing, decreasing, intervals, domain, and range, and end behavior. I'll stress that a little bit more when I get back. Okay, but just know how to graph it by plotting me at least 3 points on the function. Okay, so now what about when we are in vertex form? So when we're in vertex form, we already know the vertex, so we'll start there. So vertex. So change the sign in the middle, so it'll be negative 2, 9. So that would be my vertex. There's negative 2, 9. Okay, here is the trick when it comes to graphing in vertex form. Once you find the vertex, in order to graph it, there is a shortcut. You can do this anytime you have the parabola of a quadratic and you have the number in front, okay? So the number in front of the vertex form, that's our a. It's the same a as before. So in this case, a is equal to negative 1. Okay, it's whatever number is in front of the vertex form. So it says plot up to 3 additional points on either side symmetrically. Now here is how you use the shortcut. Whatever a is, you do 1a, 3a, 5a. Okay, so what does that mean? So 1 times a is 1 times negative 1, which means negative 1. So this tells you how much you go up or down, and then you go left and right by 1. So you start at the vertex. This rule says, hey, go down 1. So you go down 1, left 1. You go back to the vertex, down 1, right 1. Those are each 2 points on your parabola. Then you do 3a. So 3 times negative 1, because a is negative 1, negative 3. So from each of those new points, this is telling me go down 3, right and left 1. So go down 3, right 1. There's a point. Go down 3, left 1. And it should look like a parabola. So you should know, okay, this left 1, I'm going to go down 3, left 1. This right point, I'm going to go down 3, right 1. You could do it if you need another one. You do 5 times negative 1. So this says, okay, negative 5. So now it says from each of those new points, you start from the new point each time, go down 5, right and left 1. Each time you go right and left 1. So down 5, left 1, down 5, right 1. And those are the points that you plot, and that is your parabola. You literally do not need any more points. Luckily, in this case, that also gave me my x-intercepts. Won't always happen, but it did in this case. 1, 0, and I believe that's negative 5, 0. It also gave me my y-intercept of 0, 5. And in this case, my vertex is a max rather than a minimum because our graph is facing downward. Okay, then the last one I want to get to, and then I'll just leave you a few problems for work, is what about graphing in standard form? So this is standard form. So I know these are a lot of rules, but you have these notes in front of you. So first thing you want to do is find the vertex. So when you are in standard form, there's no parentheses involved here. You do negative b over 2a. So we have a, b, c. They're coefficients, they're numbers in front. So the vertex, negative 6 over 2 times a. So negative b, so here's b, negative that, negative 6, over 2 times a. A is negative 3. So this would equal negative 6 over negative 6, which is 1. And then to find the y value, you plug in to the function. You're going to plug 1 in, but plugging 1 in everywhere. So negative 3 times 1 squared is just negative 3, plus 6 times 1, which is 6. So we get 3 plus 7. So we end up getting 110 for this. 1 comma 10, I should say. Okay. Since we have a negative in front, this means that our function is facing downward. So we're going to start at 110. This is our vertex. This vertex is also a maximum, so we don't have a minimum here. And then we can still use that 1a, 3a, 5a to graph. So 1 times a is negative 3. So this means negative 3, so this means go down because it's negative. If it were positive, it means go up. But down 3, right and left, 1. So down 3, right 1, go back to the original, down 3, left 1. Okay? Now you're going to do the same thing again, 3 times negative 3. So you're going to go now from those new points, you're going to go down 9, right and left 1. So now I'm going to go down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right 1, and then, sorry, left 1, and then right 1, and connect the points. You really never need to do the 5 times a, but you can find more about graphing these online. So I at least want you to give me the vertex, the max or min, same thing. In this case, the intercepts, they don't really work out too nicely, so don't worry about them. The y-intercept does, so if your y-intercept works out nicely on your worksheet, definitely give it to me. So in this case, it would be 0, 7. Falls in nicely, and we'll talk more about increasing, decreasing intervals, domain and range, and end behavior. So what I'm going to do is I'm going to leave you a few problems. I don't want to make this video any longer, and I'm going to tell you which problems you have to do, and you have to graph me the quadratic. I do not want to hear you did not do it because you didn't know how to do it. It's graphing a quadratic. All else fails, give me a table. Okay, but you need to know how to graph a quadratic, whether it's in factored form using the intercepts, okay, plotting the intercepts, whether it's in vertex form using the vertex and then 1a, 3a, 5a, or maybe you find the vertex and picking a few more points. Okay, you can pick some x values and plug them in and see what y values you get. You can really do the same thing here. So if you're stuck, find the vertex. You need to know how to find the vertex. Shouldn't be anything new. And then you can either use the 1a, 3a, 5a rule, or you can, if you want to pick some x values and plug them in. So say you plugged in, I don't know, 2, 3, or 2 to see what you got. That's fine too. You need to be able to graph a quadratic. Okay? I hope you all have a fantastic day, and hopefully I'll be back next block. Please make sure that you watch at least parts of this so that you are able to complete the work. If you don't complete the work, you will get a 0 that you cannot make up unless you're absent. Okay, I hope you all have an awesome day, and I'll see you soon.